All right, geometry, let's finish off section 913. I hope, first of all, that you're in your electronic textbook as we're doing this stuff, that you see what I'm talking about as I go through this. The next problem, so we did this one with the box. Well, what if, instead of a box, it's like a, I don't know, chunk of cheese or something? Or what if the shape is altogether different? Like this looks like, if you take off the tip and you take off the eraser, this looks like a pencil. It's like, what's the volume of that? What's the surface area? Like, what if I had to paint that shape? That's an interesting question. And then what if I have a cylinder? And then I'm also going to talk about this thing called Cavalieri's principle. All right, so I'm going to keep this little figure here so I copy it correctly. Now watch as I draw this diagram. There's a trick to doing this, and it's not that hard to draw a prism. Really not that hard to draw a prism. So I'm looking at this shape, and what I always tell people, what the book has shared, is you just draw one of the bases. So now this is where you're going to have to be careful. Okay, so I put the little right angle box in there, and you're thinking, that ain't no right angle. Well, that's because you have to imagine this right triangle is coming out of the board towards you. 3 dimensions. So what you do is you draw one of the bases, and then you go directly below it and copy that shape. There's only one little caveat, and that is you want to draw the things that are sort of behind as dashed lines. And then, once you've copied that shape, now you just connect the vertices, connect the points. I can see the solid edges. I cannot see the dashed edges. By the way, if you're wondering, like, how do people like Mr. Kilps or somebody, how do they get decent straight lines that are hand-drawn? Put your pen or pencil where you're starting, put your eye on where you're going, and just connect. And don't take your eye off of it. Don't look at your hand. Your hand knows what to do. It's like running long distance. If you're running while looking at your feet, you're not going to get where you need to be. If you keep your eyes on your target, your feet know what to do, your arms know what to do. It's all the same. So, all that to say, that's how you draw a prism. And it was sure a lot of fun for me to try to draw this hexagonal based prism. But I'll get to that in a minute. They want us to try to get the surface area and the volume of this shape. So I take out the formulas that I know. Surface area from my other board over there is 2 times the area of the base plus the perimeter of the base times the height. So, okay, here I go. 2 times the area of the base. Okay, hold on there, Tiger. Hold on. 3 centimeter, 4 centimeter, and then 9 centimeter. The area of the base. Okay, well, the base is, so this is where you, all those area formulas in your quadrilateral toolkit that we put in there, all the area formulas you know for triangles and how do we get the area of a polygon, that's all coming together now in this chapter. You have to be ready to go from a triangle to a hexagon to a trapezoid to whatever. Okay, so keep those toolkits handy. If you didn't come in to get your toolkit, outside of my room, all your file folders are there. All your magical golden toolkits are right inside there. So you're good to go. Okay, the base of this thing is a triangle, and I know to get the area of a triangle, it's 1/2 base height. Notice this B is a little b, that B is a big B, not the same thing. This means area of base, This means the base of this triangle. I'm just going to call it 4, and I know the height is 3. Doesn't matter if you trade the 3 and 4. But here's what I know. 4 times 3 is 12, and half of that is 6. So the area of one of my bases is 6. Next, I have to get the perimeter of the base. Well, friend, that's going to take a little bit of thinking. Because my base is this right triangle, and that is 3 plus 4 plus 1. Now here's the other thing. This chapter requires, this section requires that you remember also your triangle toolkit. Remember Pythagorean triples? 5, 12, 13, work in the Pythagorean theorem. 3, 4, 5, work in the Pythagorean theorem. So, they don't give you everything, they give you just enough to solve the problem. So they want you to use those old bits of information that you know, even from your triangle toolkit. So this section is going to require that you keep all your toolkits close, keep them handy. Okay? All right. 3 and 4 is 7 plus 5 is 12. So my perimeter is 12, and then the height of this prism is 9. Now I've got all my numbers. It took me a little bit of extra math on the side. That's another piece of this chapter. Got to do a little extra math on the side. Once I get all that done, 90, 108, then I'm all good to tell somebody what the surface area is for this bad boy. 120 square centimeters. Yes. 90, yeah, 108. Good. I'm doing this in my head, sorry. All right, let's do volume. Volume is area of the base times the height. This one's not so bad. Here's why you want to do this work on the side. A lot of times they're like, what's the surface area and the volume? It's not too often they want just one or the other. So if you did the work to find the area of the base, just write it down. Show the work. Do it on the side, because you're going to probably need that number again. And then 9. The product of 6 and 9 is 54. And we're talking centimeters cubed. Now, students, this number is smaller than that number. But we're talking about cubic centimeters. 54 little cubes, the size of, each edge of the centimeter in size, 54 of those is not the same as painting the outside of this shape. These are different things. Square centimeters are not the same as cubic centimeters and vice versa. Okay? So don't let the fact that the volume, the amount of stuff that fits inside of this, is a number smaller than the surface area, the amount it would take to wrap it in paper. Different things that we're talking about. So please don't get confused. Don't get worried about it. All right. Let's move over here and talk a little bit about this. I'm going to do the same process. I'm going to do surface area and volume for that hexagonal based prism, and we're going to just keep following the same process using these same two formulas. But I'm just showing you these two so that you get a sense of the expansiveness of the various kinds of things you could be asked to do. Surface area is 2 times the area of the base plus the perimeter of the base times the height. Here's where the fun comes in. Remember that process? It was like a 4 or 5 step process to get the area of a polygon. We have to do it again. So you got to get that toolkit out too. Keep them all handy going forward. I have this situation to keep in mind. Remember, this is our apothem. This is half the side length, so this is 2 and that's 2. The first step in the process was take 360 and divide it by the number of sides, because I've got to figure out what the central angle is. Well, that's 60. But then we had to divide it by 2. And that came out to 30. So this, from this vertex up and over to that vertex, that was 60. But because I'm just focused on this little right triangle, because I might do some SOHCAHTOA, I might do Pythagorean theorem, I don't know what I'm going to do to find A, But I do know at this moment that that angle up there is 30. And because that angle's 30, this bad boy must be 60. It's a 30, 60, 90 right triangle. Gotta have your triangle toolkit, because you might not remember that you take the short leg, times the square root of 3 to get the long leg. So now I know the apothem. You might be like, apothem, that sounds remotely familiar. The area of a polygon from your toolkit is 1/2 apothem times perimeter. That's why I needed that number. So I now have to do, okay, so my area of the base is this formula, because I'm doing this. I know I'm using different letters here, but I'm keeping it in line with what's over here in these formulas. The area of my base is 1/2 the apothem times the perimeter. Well, the perimeter, I've got one side is 4 inches, and I've got 6 of those, so that's 24. Okay? That 2 cancels with that 2. This is 24 root 3. And I'm good to leave it that way, by the way. I'm totally fine to leave it that way. So I've got to do 2 of those. And then I have to do perimeter, but wait a minute, I just did perimeter. 4 times 6, 24, times the height. Height of the prism. Height of the prism is 7. So I have 2 times 24 is 48, plus 24 times 7, 140, 168. Oh goodness, I hope I'm right. 24 times 7. Glad I'm right. Hey, by the way, you should use Desmos. I'll show you in a minute what that is. It's good. It's a wonderful tool. It's an online calculator, graphing calculator. You do not need to worry about not having this. You are good. All right. 48 root 3 plus 168. Now I'm going to go ahead and figure out what my answer is as a decimal. By the way, I'm totally fine if you said, oh, the surface area is these many square inches. But if you want to know what that decimal is, I ground it out in the calculator. It's 251.14. Same units, square inches. We're talking about area. It's surface area. Surface area is done. All right. Let me go to volume. I'm going to use that same formula. The volume formula is area of the base times the height. Oh, this is great. Area of the base I already got figured out up here, right? This is why I keep these numbers handy. 24 root 3, the height of the prism, 7. 7 times 24 is 168. So my answer is 168 root 3 cubic inches, which is, 290.98 cubic inches. That's the volume. Just using this surface area formula and that one. We have found the area of a rectangular prism, that Amazon box thing I was talking about first in the last video. This weird cheese wedge shape where you had a right triangle base prism. And then this hexagonal based prism. We've done it 3 different ways. I'm going to do it in a 4th way now. I'm going to turn your attention to this problem right over here. Number 930. In number 930, what if this was a cylinder? Can I still use the same formulas? Is it okay to use 2b plus ph and big B times h? Well, it's not a bad thing, actually. Surface area is 2 times the area of the base plus the perimeter times the height. Perimeter of the base. Well, okay, we have to be careful here. We're talking about a circle, and again, did you notice? The figure, it's a prism because, well, it's actually a cylinder, of course, but you could categorize it as a prism because the parallel figures are the same shape. They are congruent. That's why it's a prism. Again, I know it's a cylinder. But I'm going to give you a more cylinder-specific formula in a second, but I want to show you that this formula works. The area of my base is going to be the area of a circle, and the area of a circle is pi r squared. And my radius is 5, so 25 pi. So I can go ahead and put that in here, 25 pi. I just leave it in terms of pi. You don't have to get the decimal yet. Wait till the end to get the decimal. It's not a big deal. Perimeter of the base is like saying, hey, what's the circumference of this circle? So the perimeter of the base is really the circumference of a circle, and there's two formulas for that. That's the one we're going to use, but there's another one, and it goes like this. Pi times diameter is circumference, but because there's two radiuses in a diameter, you could use this formula too. Okay, so 2 times the radius, 2 times 5 is 10, so my circumference is 10 pi. So I'm going to go ahead and put 10 pi in here, and this is the height of this prism cylinder, and that is 8. So if you've got 2 quarters, you've got 50 cents, and if you've got 10 times 8, you've got 80. And 50 plus 80 is 130 pi. They didn't give us units on this, so I'm just going to say square units. Again, this formula came out and was our hero. Worked out just fine. Volume, though, different animal. And we know the formula. It's area of the base times the height of the prism. But the area of the base, oh wait, sweet, I've got that right here. It's 25 pi times the height, which is 8. If you've got 8 quarters, you've got 200 pennies, or $2. 200 pi, we're talking about volume, it's units cubed. Now, notice how fast volume goes when we just get surface area done. Surface area always requires more stuff, okay? It just requires more stuff. You got to get the area of the base, you got to get the perimeter of the base, and sometimes it just takes more. But once we got that, then volume just, it's quick. It's been quick every time. All right, so I wanted to give you the cylinder-specific formulas. So I want to take a hot second and do that. Surface area, okay, so surface area is 2 times area of the base is pi r squared. And then plus the perimeter we said was 2 pi r, because that's really the circumference times the height. Honest to goodness, friends, this is the surface area of a cylinder, 2 pi r h. And if I wanted to do volume, it's area of the base, pi r squared times the height. Now in an upcoming video, I'm going to go through the entire surface area and volume toolkit. And you'll see me walk through all those formulas with examples for you, so that you can see where these formulas come from and so on. But I think this example really connects the two formulas. If you're like, oh, that's too many formulas, I don't want to have to memorize. Well, you don't have to memorize, we got your toolkit. But you could always just stick with these two formulas. They will get you the surface area and volume of any figure where you have a pair of shapes that are parallel and congruent. Okay, last thing I want to talk to you about is this thing called Cavalieri's principle. And it goes like this. So this mathematician from a bajillion years ago, Cavalieri, he said, well, look, if you have a nice stack of books like this, it has a certain volume. And here's another stack of books with the same exact volume. Even though this desk sits a little lower, you can count the number of books, it's the same number of books. So he said, well, if you make this lean, if it leans over a little bit, it doesn't change the volume. This would be called an oblique rectangular prism. It's oblique, it's off from what it ought to be. It's not quite right, right? Like this is how a box would look. A stack of books looks like this. And we don't like to stack books like this because we're worried they're gonna fall over. But his question was, well, so what if it's tipped over? Does it change the volume? No, it's the same volume. That's the Cavalieri principle. So you still need then, if you were only given this, you would still need the height, the width, and the length to get the volume. It would be the same formula also for surface area. It's the same process, even though you have that oblique shape compared to the original sort of normal shape.